Okay. Can you guys hear me all right?
Yes.
Okay.
Yes.
Can you see the homework?
Yes.
Alrighty. So let's do 2-2 and 2-3. It's not too bad once you see the idea. I'm sure a lot of you have already done it, but I want to go through it, make sure there's no problems, and if you need extensions, it's not a big deal. Just let me know. I just don't want you to rely on it because I want to make sure you're on schedule or ahead. If you keep assuming I'm going to extend it, then you'll get behind. Does that make sense? It's just how we are. But I don't mind helping you out. I want you to do well. But we're going to need a grapher for this. Uh, yeah. So the first idea, let's go ahead and graph this guy and try to figure out what the hell a limit is. I'm hoping you saw the videos and you tried this out already. So you have some idea what it is, but how exactly do you do this and what does it mean visually? Let's do that part. Okay. Y'all can see my graph and the homework, right? Okay.
Yes, sir.
Alrighty. So so one technique, the first technique for finding limits is just plugging in numbers approaching the limit. So first of all, what does this mean, right? This notation. You see this right here. As x approaches 7, they want to know the output. So what is the graph doing as we get closer and closer to 7? So let's mark it on here. S equals 7 is right here. So here's 7. So as I approach from the left side, what is the function doing? All right, so as the x's get closer and closer to 7 from the left, the question is asking, what are the y values doing? In other words, what is the function doing? See how it's getting closer and closer to 0.168, 0.167 from the right. Same deal, right? Same thing. So basically what they want you to do is plug in numbers on the left side, 6.9, 6.99, 6.999. I'm getting closer and closer to 7 on the left side. So basically they're doing this by plugging in numbers. So, all right, what's going on? Plug in numbers, plug in numbers. So you just basically punch in your calculator and give it the output, the y value. Do it on the right-hand side, 7.01, 7.001, and then you'll see the numbers approaching something, assuming the limit exists. Right, so here you can see the limit is real, right? From the left, from the right, the limit is going to be something. We said it's going to be about 1.66, right? That's basically all you're going to do here. Plug it in and see what happens. Does that make sense what they're asking here? So basically you would plug in, if you're gonna do it in your calculator, let me see. Uh, 1 second, let me get my graphing calculator, or I guess I could do it here. So if you had an old calculator, so put parentheses for the top. So if I want to put 6.9 minus 7, that'd be on the top, divided by, I guess it did the fraction for me. Then you'd put 6.9 squared minus 8 times 6.9 plus 7. See how it's getting closer and closer to 1.6. So you do that again, right? So I would just copy it. So you know what? I want to do 99 this time. So getting closer and closer from the left side. Do it again. 99. So numerically, we can see, oops, 9. We can see what's going on, right? You see how it's getting closer to 1.66, 1.66, closer and closer to this value right here, the Y value. It's technically undefined at the actual point. So it's undefined there, but the limit exists, meaning what are the values approaching from the left and right? And then once you see it approximating something or approaching something, then that is the limit visually. So they want you to do this. They want you to find the limit by plugging in numbers from the left and right. Do you see what they're asking? Is there any question on what is a limit visually?
No, I guess.
Make sense?
Can you do one more example? I just want to kind of soak it all in.
Yeah, let's do a couple here. We're gonna do limits for a bit today. Let's do this one here. All right, I'm gonna make another one. 2 sine x over yeah.
I have a question though. For an exam, we can't be using decimals, right?
Well, for this exam, you just need to explain yourself. It's a very different kind of test because you see how I'm not solving anything, right?
Yeah.
You just need to explain yourself. Like, what is the limit? Well, you would say as I approach from the left, the y values are turning into this. As I approach from the right, this is happening. Therefore, since they are the same, then the limit is that number. That's how you would answer. If they are different, then you would say the limit does not exist,
Oh, okay.
which I think happens later. Right now, I think they should exist, but let's check this guy out. This one is asking what's going on as the limit approaches 0. So basically they're asking let all the x values approach 0 from the left and right. But here's 0, right? That approach from the left, it's approaching what number on the y?
2.
2, right? And from the left side is 2. From the right side, it's also 2, right? Yeah, so basically, Corey, the limit is showing like, well, I can see what's happening, but it technically doesn't exist when I get there, but I can see the function approaching it. So the limit is a little bit different. So the limit can exist, but the function will be undefined there. So you can see this function right here, right? I can divide by 0, but the limit exists. We can see the function doing something as I get closer to 0. So we use the limit because we can't plug it in. So we use ideas of infinity and limits to kind of figure out what's happening. Does that make sense? Okay, so visually that's what's happening, but here they're not asking for a visual, right? I just want you to be able to see it. Here they're basically saying plug in the numbers as they get closer from the left. What does it happen? What's happening? You should get outputs getting closer and closer to 2, right? Because we can see it happening. So as I plug in numbers closer to 0, the output will be closer and closer to 2. So from the left side, you'll get answers approaching 2. From the right side, same thing. If they are approaching the same thing, then the limit exists. If you go to two different places on the left and right, then you would say a limit does not exist. It has to be approaching the same thing. And you would see that. You would see like this number is going to something else completely different. Instead of 2, you'd have like I don't know, a 10, and over here going to -7 or something. But check this guy out. As I approach this thing, this is just a line. Excuse me. As I approach from the left, as I approach from the right, all right, as I approach, what am I approaching? It says,
Never mind.
you see it, right? As we approach, we approach 3. What are the Y values doing? Now we're approaching 2. Does that make sense? So in this case, you can't, it does exist. You can plug it in, right? But you can also see what are the values approaching from the left and right. Well, it's approaching 2. Therefore, the limit is 2. Is there any questions on this?
So the limit is just what it approaches to, like both sides.
Yeah, so right here, since it says just 3, then that means what is well, first of all, they both have to be approaching the same thing. So if they're both approaching 2, then the limit exists at 2. But if they're going to something different, like if the right side is going up here, left is going down here or something, then you would say it does not exist. But the first thing you should try is plug it in and see what happens. You can see if I plug it in, I get what?
2.
Yeah, so I mean, it was obvious from the beginning. So the next step would be, well, if I can't plug it in or I don't want to, well, what does the graph look like? And then we just showed that, right? This is approaching 2, right? And then the other method would be plugging in numbers closer and closer to 3. And you're going to see that it's getting closer to 2. So these are technically multiple methods, right? So the first method is plugging numbers closer and closer and see if they're the same on the left and right. But you should always try just plugging it in. The other method is graph it and just see, okay, well, what's happening? And then when you have the graph, I think it's a lot more clear as to what's happening. Because the idea of a limit is very complicated, but when you look at the picture and just talk about it, it's not that bad, right? That makes sense. Y'all agree? If you look at the definition or the theory, it can be intimidating, but if you understand this idea, it's not that bad. Any questions on the first couple examples here?
No.
Was for the bottom answer. Let me see. For number 5, Corey, or which one? First question. Yeah, the first question is basically what is the actual number they're approaching, right? So in this one, it was what 1.66 or something. Yeah. This one was 2. This one's also 2. Any other questions? All right. Let's pick at this one right here. All right. So notice how this, so do you guys remember piecewise functions? It's basically you're just going two functions together, right? You got, in this case, you got a parabola and here, and then you have a point. You can have a line and a parabola. You can have a, you can have a cubic and a square root, whatever. You can have 3 or 4 functions glued together, or I guess graphs that create a function, as long as it fits the definition of a function back in college algebra. So this guy just has a parabola. So the way if just to refresh you, what this is saying is you have a parabola everywhere except at -1. So everywhere else you have a parabola shape. At -1 though, when you actually do go there, you plot this guy, which is this point down here. So the question becomes, well, what's the limit? Because the value is the output is -2, right? Right there. But the limit is different. Do you see what I mean? All this whole chapter is just very conceptual. So approach from the right side and the left side. What y value am I approaching?
-1.
Well, we're
Well,
approaching the x of -1, but what's happening to the y's?
0.
Yeah, you see how the y's are going to 0, right? So the limit would be 0 because it's the same on both sides. If it wasn't the same, then you'd say it does not exist. See how they keep asking you if it exists. So let's say it was going to 0 on one side, then over here is going somewhere else or whatever. Then you would say does not exist. The single-sided limits do exist, but the actual question here does not. Does that make sense? Which we'll talk about one-sided later, but here the limit is 0. The function is defined at -2 though, because of the point here. Anyway, any question on number 5 or 6? That okay? So far, not too bad, I hope. I'm trying my best to make it as simple as possible, so let me know if I make no sense. That's why you're here. Don't be scared to ask me. Okay. I'm gonna assume that you're all super pros. Cool. All right. So check this guy out. -4 is, let me see, right here, right? So what is this limit? What's happening?
There's no limit
There's none, right? Why is there no limit? Because you got to explain yourself on the test.
because from the top you got +1 and in the bottom you got negative.
Yeah. So from the right side, right, the limit from the right is a 1, which is not equal to the limit from the left. They must be equal. Otherwise, there is no limit. It's D and E. So limit on the left is -1. Limit on the right is 1. Okay. They didn't ask for left or right. But if they did, that's what you would say. But since the limits are different on a test, you would say a limit does not exist because limit on the left does not equal limit on the right. Because they're different. As somebody just said, the other one's 1 and the other one is -1. Okay. Does that make sense? All right. So let me know. It's all conceptual. We're not really solving stuff. You see how chapter 2 is very different from the usual math stuff? It's just, do you understand the idea? Do you understand the definition? Do you understand what is a limit? Can you find out if it exists? Can you find out if it's what's the limit on the right or left, and etc. Okay. Limit as x approaches 0. All right, well, so we approach from the right side. We're going to what number?
Zero.
0.
0, right? And from the left?
2.
2.
2. So because they are not equal, then
D and E.
yeah, not exist.
I have a question.
Mm-hmm.
So if it was asking for what you said earlier, a left-handed limit or like a right-handed limit, then that's like that's answering a different question, and right? Okay.
Yeah, so if they said, what's the limit as x approaches 0 from the left, you would say 2.
Oh,
If they
okay. So
say from the right, you would say 0. And they have some symbols that mean if it has a minus on it, see, like right above, like if they would have had a little minus above the 0 right here, then that means from the negative side, which is left side. If they have
oh,
if they have a plus, then that means from the right side, which would be 0, which we'll talk about real soon.
but for this chapter, it's just asking like whether it is or not a limit.
Yeah, because it has to be the same on both sides. So as soon as you see that they're different, it does not exist. But to explain yourself, you would say, because the left and right are different, then there is no limit. Leave these guys to you. No, on number 10, do y'all remember, just in case, do you remember what this means? The f of 6, f of 1? Do you know what they're asking?
Find the function. She kind of forgot.
Yeah, it's what is the function doing at 1, right? You input 1. So what is the output? So in this case, it would be 2 because 1's right here, right? So this answer would be 2. At 6, what's going on there? Well, here's 6. What is it doing at 6? Looks like it's 2 again. No, that's not right. 6 is not defined. Yeah, I said just D and E. Let me see if it lets me write. Dang it. Usually it lets me try it out, but yeah, you would say D and E on this one because it's open. Over here, we are defined at 2. And then you do the limits for B and D. Anyway, so big picture, right? 2.2, do you understand what a limit is? Can you figure it out by plugging in numbers closer and closer to the X they're approaching? Can you do it visually? Can you do it with piecewise functions? Can you do it with this type of function? I think it's a step type, etc. Do you have any questions on 2.2?
Can you explain what we do in the first question again? That one,
Number one?
Yes.
So all you're doing is plugging in these numbers into all the X's and see what is it approaching. Okay, so that's what we did right here. So when I plug in 6.9, I get this number. When I plug in something closer, 6.99, closer to 7, I get this. Plug in 6.999, I'm even closer to 7, I get this. So basically, we're trying to figure out what the heck is the function doing as I get closer and closer to 7 from the left. And then you do it for the right side, closer and closer to 7 from the right. And you're going to get 1.66. So just plug them into your calculator. That's all. Let's see. What's up, Chance?
I forgot to say this, but in WebAssign, there was the assignment that was getting started with WebAssign. I tried opening it and it wouldn't open. It said like something about the instructor. I don't know if there was something I missed.
Yeah, I was having a lot of problems last week. I'm just gonna delete it, so don't worry about it. I'll probably just turn it off.
Okay, just want to make sure. Thank you.
Yeah, sorry about that. I don't know why that happened, but it doesn't matter now. So I haven't posted the ISO yet. I'm gonna do that after midterms, so don't worry about it. I'm hoping at this point you've done all the orientation. I haven't completely graded it yet, but at this point I want you to be finished working on 2.1, 2.2, 2.3. 2.1 is kind of just some conceptual ideas. 2.2, we just talked about it. Now let's talk about 2.3. More limits. So here they don't give you any graphs, I don't think. Yeah. So let's talk about this one. Should write it. We'll call it a night after 2.3. It's gonna take too long. But if you have questions, we can hang out for a bit. Analytical, okay. So the first one has no graph. So basically just graph this and see what the heck is happening at -3. What is the parabola doing when x is 3? Kind of already know, right? As I get closer and closer to 3, the y is going to 9 from the left side. And from the right is also going to 9. Since they are the same, the answer will be 9. Oops, -3, but it's the same, I guess. -3 is over here. Same idea. From the right side, I'm approaching 9. From the left side, I'm approaching 9. That's all they're asking you to do. You can also just plug in the number. If it lets you, then you're good. But you should try to see it visually. All right. Number 2. Who's on top? All right. So as we approach 1, what is the graph doing? As we approach from the left side, the y's are going to 2.4-ish. From the right side, sorry, 0.24. 0.25. Yeah. So I'd say the limit is 0.25. But try plugging it in, you should get the same thing. So what I could do, since I labeled it as a function, plug in f of 1 and see what happens. The output is the same. Since there's no holes, there's no weirdness, the output should be the limit. Any questions on 1 and 2?
I have a question.
Mhm.
It seems like there's two ways to solve these. You can solve it like in a visual way, or you can solve it like in a mathematical brute force kind of way. Which way will you be expecting on the test?
I want you to use the best way for the question, for the problem in question. So, for example, the first one, I'd say just explain that the limit on the right and left are the same. Therefore, the limit is going to be 9, right? That'd be sufficient. Same for 2, but look at number 5 and the first 2. You could plug in numbers closer and closer to -3 from the right, from both sides, right? And that would also be sufficient. But that's also kind of annoying, especially if it's simple. So certain techniques are better than others for different problems. None of them are wrong, but you'll see some are easier depending on the question. All right.
I've been utilizing the trace and table functions to find the limits for the ones that are a lot harder.
Mhm.
And I just worry that, I'm gonna get flagged on the test because I don't show my work for those.
Well, that's a good point. There is there might be a few questions where it asks you to do it analytically. For example, number 5. We could do it your way, and it's not wrong, but if they specifically say do it using analytical techniques, then you're gonna have to do it this way. Let's do that guy on paper. Find the limit. I already forgot what it was. Let me get the question out. 1 second. You guys can see the paper?
Yes.
Yes.
Okay. -3. So what they would want you to do is use algebra to help you out. It's an arrow. So the top part is a difference in squares. So you should see that it factors like this, right? Once it factors, you should see that these cancel. So now, when you're able to take the limit, in other words, plug it in, do so to find your limit. Now, if you're to do the trace, you're going to see that it's approaching -6. So if you're able to plug it in, then that is evaluating the limit. If you can't plug it in, then use various techniques to get you there. If they don't tell you to do any specific technique, then just explain yourself. Explain how what you're doing with the trace. Does that make sense?
So we can use the table and trace and graphing functions on the calculator so long as we explain what we did on the calculator.
Yeah, explain like, well, why is the limit -6?
Okay.
So you would explain, right? As I approach the graph, as I approach the x, a value of -3 from the right, I'm approaching -6. As I approach from the left, it's also -6. Since they are equal, then the limit is equal to, right, this limit of this guy as x approaches -3 will be this. But if they ask you to solve it analytically, then you'll have to do algebra or another technique. So you have a couple in there where they make you break it down. So we've done a couple of techniques. So the first technique was numerically, right? Like you said, the trace thing is basically, this is the same thing as plugging in numbers closer and closer from both sides. That's the first technique. Now the other one was look at it graphically, what's happening. And then the third technique we just did is algebraically. analytically, factor stuff, and then plug in the number. There's a few different types of ways to do it analytically. Do you have any questions on this example?
I have a stupid question regarding on the exam.
Mhm.
So when you want us to show it, do you mean like talk about it, or do you mean like writing it down after and then uploading it on the Canvas, or like writing it down what we did?
Well, all the stuff I'm going to be grading is whatever you write down, right? Now, if there's nothing to write, then okay, cool. But most of the time, you're going to have to explain yourself, right? Just because you choose the right option doesn't mean you're going to get credit. You have to explain why is it -6. And if you show this work, then that's cool. If you do it a different way, then you better explain why is it -6. Does that make sense?
Yes.
I have a follow-up
So,
question on
oh
that.
yeah,
So say we are about to run out of time and we guess on the last question. Are we gonna be marked wrong regardless because we couldn't show any work?
yeah. If there's no work, there's no credit. I mean, like I'll give you the answer. I don't really care. I want to see, can you get there? You know, that's what matters. Now, after you're done, you have 30 minutes to upload your stuff so you can kind of try to make it pretty or finish up. So you have some time. I'm gonna try to give you plenty of time to work this out. Okay. But the tests are not that long. I think this first test is like maybe 8 or somewhere between 8 and 12 questions. It's not too bad.
Say we did run out of time, but we had enough time to write down the question in the work and we solve the question in the work anyway. Would we get partial credit for that?
Yeah, yeah. I mean, if you upload your, I'm gonna grade only what you write down. So I don't care what answers you choose. So I'm just gonna look at this. So you're gonna scan this, upload it, and that's what I'm grading. Okay.
So we need to put our answers on our work, what we came up with.
Yeah, every question, write it out. If I
Gotcha.
feel like the question didn't need work, then I'll just give it to you. But for the most part, you'll be required to explain yourself. Just work it out. You'll be good. Now, if you mess up at the end, but your work's decent, I'm probably gonna give it to you 100% credit. It's fine. I'll give you partial if you started out pretty good and then you just forgot, I'll give you pretty good credit too. Okay, I'm not gonna be difficult about it. Does that make sense? I'm trying to help you out. What I don't want to see is the answer is 7 and then you just move on. I don't want to see that. Yeah, you just work out the problem. What I want to see is how did you get there? And that's what I'm testing you on. I already know the answer. I want to I want you to show me how to get there. Okay. Is that clear? Or that's how math should be. And as you get further and further, they're going to be more strict about it.
So we shouldn't take the score we get immediately after the test as our score. We should just assume that that's invalid for the time.
Right. Yeah. Basically, that means nothing until I look at your stuff. So if you get a horrible score, if you get a 0, but all your work is awesome, then I'm probably going to give you a 90 or 100 or something. But if you get 100 and your work is garbage, then you're probably going to get a horrible grade. Does that make sense?
Yes.
So yeah, the first preliminary score doesn't matter. Just I need to look through your stuff. If you upload nothing, then you're in trouble. Okay, so we just did number 5. 6 is the same thing, but they're doing a sum of cubes formula. 7, they're forcing you to break it down like we just did on paper. Except they make you do step by step by step. Righty. 9 is a different technique. So let's do that one. Do you remember what conjugates are? Okay, so whenever you see a square root like this, square root of something plus or minus something, you should think, oh, I should probably use the what's it called? Conjugate technique. So yeah, you could use trace, you could graph it, but if you say do this analytically and show your work, this is what we got to do. All right, so multiply the top and bottom by the conjugate. So conjugate is usually referring to like the difference of squares, right? So these two are considered to be conjugates. And when you multiply conjugates, you get a difference of squares. The reason we care is because this basically forces you to square two terms. So I want to square the square root, but I can't just square one thing. I can't square the whole thing because I don't have an equation. I can't square top and bottom because that's not a thing. So what I can do is multiply by the conjugate and force this scenario here. So I'm forcing this problem into a difference of squares. That makes sense? So since I have a -1, I'm going to multiply by plus, hence conjugate pairs. So once I have conjugate pairs, it's going to turn into this. The bottom won't, but the top will. To the top, I'm going to get this. I'm going to show this step real quick. The bottom's not going to multiply. I'm just going to leave it like this for now. So one fraction. So the top's going to turn into this squared minus this squared. I'm sorry. This squared minus that squared. If you were to do the whole multiplication, the whole FOIL, you're going to end up with this. I'm going to skip a step, but this is what you would end up with. That's why I did this, in order to square this on purpose. Do you have any questions before we go any further? Do you see what we did?
Yes, I have question.
Mm-hmm.
On that second step right there, where you have the two, I guess, fractions divided or multiplied by each other, how did you get the denominator to be the square root of x plus 1 plus 2?
So I'm multiplying both the top and bottom by x square root of x plus 1 plus 2. So this, right, times the top, and then this times the bottom. So I haven't done anything yet. So I'm basically just combining these two into the same fraction.
Thank you.
You see it, or?
I think so.
My bad. Can I ask you something, sir?
Mm-hmm.
So when that -2 times the square root of x plus 1 and then the 2 times x plus 1, that canceled each other out. That's why that's not in the numerator?
Oh, right here?
Yeah.
Oh, from
'Cause
here to here?
how you said like you skipped a step?
Yeah. So basically, so we don't mess up this page. What we didn't show is all this right here. This is just scratch work. So this times this, you agree it would be squared, right?
Yes, sir.
This times this is 2 of them. This times this would be -2 of those things. So these are going to cancel, right?
Yeah. Okay, just making sure.
And then the last one, 2 times 2. So that's what we end up with, just this. But the reason, the bigger reason, is because they're conjugates. So they will always turn into the first thing squared minus the second thing squared. The first thing squared minus the second thing squared. Now I'm talking about these two things, right? You see what I'm saying?
Yeah, I just don't even remember the conjugate thing, so I always, yeah, I forget. So
So yeah,
thank you.
just remember the difference of squares.
Okay.
That's where it comes from here. Back in shoot, when was that? Middle school, maybe 6th grade, maybe 8th, around there somewhere. We talked about this a long time ago. It's familiar, right? So we're just applying it to something more difficult.
What confused me about this problem is that in pre-cal we spent the majority of the course we didn't want a radical in the bottom. We wanted to rationalize the denominator, but in this case we do want the radical on the bottom, right?
Yeah, you're not wrong. Yeah, usually we would do this technique to get rid of the radical on the bottom. Here we're just we're trying to allow ourselves to take the limit. So we're hoping by doing this that then maybe this will cancel, and then I can plug in the 3. That's the purpose. Let's see if it works. I don't know. But when you're doing limits and you see radicals, just multiply by conjugate and see what happens. So this becomes x plus 1. This becomes a -4, right? Do you see what's going to happen?
Ah, I see.
So those are gone. So now you can take the limit. But you're right. We don't usually like radicals down here, but that's not the goal. The goal is, can I plug in 3? Originally, we couldn't because we'd have division by 0, right at the beginning. But now we can.
I think it's only important if the answer is the one that has the radical on the denominator, but in this case, the answer is the limit.
Yeah. Yeah, the goal is to find the limit, which is this.
If the question has a radical in the denominator, do we still use the conjugates to try to figure out if something will cancel so we can simplify it to find that limit?
Yeah, assuming you can't plug in the number in question. Like, we couldn't plug in 3, right? Right at the beginning. I didn't mention that, but you should have seen that I cannot plug in 3. So therefore, I need to I need to choose a technique to find it analytically. So when I see square roots, that triggers my mind to use this technique, square root conjugates. So once I do it, then I get to a point where, oh, I can plug in 3, cool. And what do I get? 1/4. If I would have graphed it, I would have known it's 1/4. If I would have plugged in numbers closer and closer to 3, it would have gotten a 4th. But you would have used trace, it would have gotten a 4th. But they want to see the actual work for this type of problem. So we got to do this, even if we know what it was. Does that make sense?
Is 1 over square root of x plus 1 plus 2 the same as the original problem? Like that's the same formula, the same function?
Yeah, this one is equal to the original. Yeah. This was a form of 1, so I did not do anything to change the original. All this is equal.
So I think where my brain is breaking here is we can't plug in 3 to the original function, but we can to the new simplified function. Why is that?
Yeah, technically the original function is undefined at 3, but the limit exists at 3. Remember how we had those examples earlier of the visuals where there was a hole? So, but visually you could see it was going to some number, but you couldn't plug it in. That's what this is an example of.
But they are the same exact line, the new simplified function and the original function, right? They're the same curve on a graph.
Right. But this is 3 is technically not defined here. It's technically not defined there either, because it was originally this. I'll give you an example. If you had the function X plus 3. You agree that I can plug in 3 and get 6, right?
Yes.
Now, what if I had this function? Let's see if I can come up here. You see how plugging in 3 would cause problems? It would be undefined, even though I can technically cancel this and still get 6.
Yeah. That's just weird that
So this is so 3 is undefined for G, but it's not undefined for F, even though they are kind of the same. But because the original had this built in, this F never had it to begin with, so it's cool. But the G had it to begin with, so it's not cool. So if you were to graph it, you will see this goes back to college algebra. For example, I think we called this G earlier. No. We said F of 3, right, is 6, correct? For the blue F function.
Yeah.
Now, the G function is technically the same, but not really. As we approach 3, we end up undefined. There's a hole there. So G has a hole, F does not. So we cannot plug in 3. But the
So
limit exists.
is g of x equal or not equal to f of x?
They are not the same. But when it comes to limits, um, when it comes to limits, it's a little bit different. But I see where your question is coming in. Let me find the graph here. One. Reading up here. Can you guys see the paper or no?
Yeah, we see it.
Yeah.
That's weird. I think my computer's crapping out. That's well. Sorry, guys. I don't know what happened to my.
Do you need to restart the Zoom call?
Maybe. Do you remember domain and ranges of functions? You know, when you did the composites, the f of g and g of f back in college algebra.
Yeah.
So the domains of f and g will differ because of the way they're composed. So this is composed of more than one function where f is not. So yeah, graphically they look almost the same. The domains are different. Hence the whole idea of one of them has undefined, one doesn't. So remember how you would find the domain of f versus f of g, and you'd have a different domain where some stuff was defined and then later it's not. That's basically what this is coming from. So they're not necessarily equal, but they kind of are. It's kind of weird. I need to find a better term. But for now, we're trying to find a way to allow us to plug in this value to find the limit. Okay. If this thing would let me share my screen. Hmm. The document camera just keeps freezing up. All right, sorry about that. Let's see what I can do here without it. Okay. So as soon as you see a square root, think conjugate technique, okay?
Gotcha.
If you see stuff that you can probably factor, then attempt to factor and see if stuff cancels and then plug it in. Conjugate and then plug it in. All of these are factoring and plug in your number. The first two, you can just plug it in and see what happens, and you'll be fine. Here you can plug it in, but there's a rule that you can use. It's in the book. Yeah. Might need a better computer. It's all right. I'll troubleshoot later, but let me write it on this homework right here real quick. So this is the rule from the book. If you have the limit of sine x, whatever this x is, could be multiple things like x plus 2, could be w plus 7, whatever is inside the sine, right? If that same thing matches on the bottom, whatever that is, as the limit approaches 0, then this becomes 1. Let's check. I'm doubting myself. It's either 0 or 1. I don't say it's 1. Double check. I don't trust myself anymore. Yeah, that's one. Out of paranoia. But notice how down here there's a 2. So it's almost the same, right? It's all you got to do is pull this half out and you're good. So just think of this as 1/2 times the limit. As x approaches 0. So this whole thing goes to 1, so you end up with 1/2 times 1. So the answer is 1/2. Okay, so basically you're trying to force this into this form here. Okay.
So the limit x approaching 0 can be seen as a variable representing the solution to the problem it's preceding.
Yeah, so think of this as a formula. There's a whole proof as to why it's 1, but we won't get into it. But if you can force this form to appear, then we know that will be 1. That's what I did here. I changed this guy to be this. You see what I mean?
Yeah, it's kind of like logs, I think, right?
Yeah, we're just sort of manipulating what we got to turn it into until we can use one of our formulas. That's all. 11, you would use your pre-cal to turn it into this. And then you'll end up getting something like 1/9 or something. Yeah, I think it's 1/9. Oh, excuse me. But since my camera's being stupid, I'm gonna, well,
Sir,
mhm.
for number 10, so is that only apply when it's kind of like, I don't know, when the limit's approaching 0, does that only, like, what if it was approaching like any other number?
Yeah, this is only when x is going to 0. Then you can use this formula.
Okay.
If it's
And
not
then-
going to 0, then we shouldn't be talking about this guy right here.
Yeah. And in her video, she was like, you can't just say like, oh, you knew it, because I don't know, she was like, you got to show some kind of work, I guess. And I was trying to figure out, how can I show like the work? Because on ours it was just like sine 3 over like 4 or 5 over 6, so we would just put like 5, 6, 3/4, and that was the answer.
Yeah, you gotta show your work. So
Wasn't
for
really sure
example,
how to show it, so I might come a later day and talk to you about that.
so this one we just showed it by pulling out the half.
Yeah.
But the one you're talking about would be more like 14.
Oh, okay.
You see how they're not the same, so I can't do it. But what I could do is pull out the 8 in front, 1/8, and then bring in a 9 on purpose. So I can do algebra to help myself out. So I can first step pull this guy out. Let's do it in steps so it's not confusing. And I'm going to use x because My T's are weird. So now I'm almost there. I just need a 9 on the bottom, right? And then I can use the rule. That looks stupid. So how do I get a 9 down here? So what you would do, stupid camera thing. So I need a 9 in the bottom, so multiply the top and bottom by 9 on purpose. So now I have a 9 on the bottom, right? So let me write it out a little prettier. I'll have 9 sine 9 over 9x. So now I have the rule because these pieces match as the limit goes to 0. So once you take the limit, that piece will become 1, so I'll end up with the 8th hanging out times the 9 times the 1. So the answer becomes 9 over 8. So she's saying, don't just put 9 over 8 because you can see the answer. Maybe you can't see it, but if it was obvious, maybe an easier one, you would plug this in. So what you would show is this work here. Does that make sense?
Yes, sir. Thank you.
All right, guys. So I'll post this video later. And we'll stop here for today. So this is so that's 2, 2, and 2, 3. So next week we'll talk about 2, 4, and 2, 5. If you need any extra time or extensions, let me know. And then we'll probably talk about the review as well next week. A week after that, the tests will be open, so you have any time the following week, 2 weeks from now, to take your test. That's a ways, but for now, focus on getting chapter 2 done. Like next time, we'll talk about one-sided limits and the definition of continuity. Y'all have any questions about anything?
Can you open 2.3? I couldn't finish like last night.
Oh, did it close already? Yeah, I got you. I'll do that before I go to sleep.
Oh, yeah, thank you very much.
Yes, me too for the 2.2. I need to finish that up. Sorry.
All right, I'll open all of the 2.1 through 2.3. Okay. Just give me like 20 minutes or less.
Thank you, because I needed that too.
Yeah, no worries. I got you. And any other questions or concerns? Alright, yeah, let me take roll in just a moment. Yeah, I didn't see that they closed. Oh, they closed last night, I guess. I'm gonna remove getting started and change these guys to. So they were due yesterday. Alright, I'll put it due Sunday, okay? I prefer you do it way sooner, but just in case. Assuming at this point everyone's installed Respondus and you did the practice test, right? Because every test will have the Respondus lockdown browser. You have any issues with that? Did it work?
It worked for me.
Yeah, so make sure that's ready way before test time comes. If you have issues, let me know at some point. Okay. Is Dana here? Dana Almanza Ventura? No. Leandro Burgos? No, Leandro.
Yes, I'm here.
Oh, okay. Evelyn.
Right here.
All right, cool. Adam,
Here.
Astrid Lopez,
I'm here.
Simon Metz,
Here.
Kesamar,
Here.
Brienne Pettis,
Here.
Serena Rayburn. Not Serena. Vivian.
Here.
Okay. Did I get everybody?
Did you say Michelle? Is Michelle on there?
Are you in what section are you in?
I don't know how to check that. So I just came just in case.
Oh, okay. Michelle Mais.
Yes.
I think you are in. Double check. One moment. Yeah, I think you're in the online only, but you're always welcome to come. So you're the only one that's not required to be here. But I combine the classes into one, so everyone gets the same material, and you're welcome to attend. Okay.
I'll probably keep showing up because I'm having trouble on some of these.
Yeah, I recommend it. You might as well. That's that way you can not be completely on your own, you know. Okay. Y'all have any other questions?
Sorry, one more. Was that practice test? Is you gonna grade that one for real?
It's not gonna hurt your grade. It's just to make sure that you know how to take a test.
Okay, the preview of like what we knew from pre-cal. Okay, okay.
Yeah,
Thank you.
it's also kind of just to see what you remember, you know. It's not gonna hurt you if you felt bad about it or something.
And you said that that test is going to be automatic 100.
Yeah, as long as you do it, I'm just gonna check you off and move on. It's not a real test. But it would it would be similar to an exam, so you know exactly how it's gonna work. Okay. No, that was
Are
the
you
idea.
are you going to review the footage from that to make sure that we have the proper testing environment? Because that's something I was concerned about. Because
I mean,
very
if there's
cramped.
anything, I mean, usually it flags you for something weird, but I mean, if you can try to do it in a quiet place, that'd be great. But if that's a difficult thing, then I understand as long as it's not you're not at the club or something, you know.
For the textbook, I'm having trouble gaining access to it. Should I have found that somewhere in the orientation?
Yeah, let me show you what it's at here. If you when you get to your homework, let me see. I can show you.
Yeah, because I saw on your homework it said that you had like a link for the ebook, but I don't have that.
Usually I try to make a link, but maybe I didn't post it. But it's inside the homework anyway. So when you get into your homework, you can just click ebook and it should pop right up. It's somewhere inside your actual homework, it'll be there. Or when you're working on a homework, there should be an option somewhere for ebook, but mine looks a little different. So I can't completely do it. US student, okay, maybe that'll work. Yeah, so just up here, my ebooks. Does yours look like this?
No, I'm actually not able to access that screen.
You click home, maybe? Somewhere?
Oh, this is WebAssign. Okay.
Yeah, the links in Canvas will send you to WebAssign.
Okay.
But yeah, it should be in here.
So homework is administered through WebAssign, right? Is anything from the book given, like, are any assignments given from the book, or is it just from WebAssign, or is that the same thing?
It is technically the same. A lot of the homework questions in the book are pretty much the same ones in WebAssign. But as you finish it, it'll grade it and it'll send the grades to Canvas. The exams are in Canvas, so when you take those, then that'll pop up as well. So everything will be transferred to Canvas, and your grade should over time be reflected there. You guys have any other questions? All right, guys. Well, if you have no questions, you're welcome to head out. If you do, let's stick around for a little bit.
Thank you.
Thank you.
Thank you, sir.
Do you have any in-person lectures? Or you just have solely online?
I have fully online and then remote currently. Sometimes I do in person, but since I've been doing night for a while, don't do it too often anymore.
Oh, okay. Alrighty. So then the best way to reach you is either like just for mine or like the Canvas box, right? Just
Yeah,
in case.
you can also if you tell me like with a day before, say, hey, I need to talk to you, or can you help me with this? We can always meet up on Zoom during my office hours, like around 9 or so, and we can just work on stuff together.
All right.
Just let me
That's-
know. If no one tells me anything, I just sleep or eat breakfast. So
Oh, okay. But I have to like, let's say I wanted, okay, wait, oh my God, what are your office hours? Hold on.
it's like 9. I think it's like 9 to 11, 10 or 10 to 11, something like that. I forget. Let me see.
Yeah, I don't know.
Let me check. I should know that. My bad.
Mm,
Yeah, it's 9 to 10:15, Monday through Thursday. So just let me know with time, at least 24 hours ahead of time. That way I'll be there waiting for you.
Hold on, let me see. Office. My bad. Monday through Thursday. You said 9 to 10:15?
Mm-hmm. And the syllabus has a link. Just click on it.
Okay. All right, I'll go ahead and do that. If I need them to do one tomorrow, I'll probably message you like, I mean, you'll be asleep, but I don't know. Because I stay up
Yes.
really late, Mr. Gonzalez. I really do
Oh,
stay up
okay.
late. So,
Yeah, I mean, I guess if tomorrow's what, Thursday?
yeah.
Yeah, I guess if you message me really late, just give me a bit to get on. No big deal.
That's fine. Oh, yeah, that's fine.
If not, the day after would be great. But since I'm not going to be there Friday, I'll make sure to check this morning or tomorrow morning.
Oh. All right, that sounds good. Thank you.
Okay.
Have a good one.
You too.
Oh, I also have a maybe a little bit of a silly question. Did we have
Uh-huh.
class Monday? 'Cause
No, that
I
was Labor
tried.
Day. I forgot to.
Okay.
Yeah, I'm sorry.
Yeah, I was sorry. I was a little confused. I tried joining and I just assumed it was Labor Day, but I didn't see anything, so I was a little worried.
No, that's my fault. I mean, I know it's on the calendar, but I should have reminded y'all.
Okay, thank you.
No worries.